In Module 10, Section 4, we will add and subtract rational expressions with different denominators. As stated in the previous section, to add or subtract rational expressions with different denominators, we have to change them to equivalent forms first. Here's the process. Step 1, we find the LCD of the rational expressions. Step 2, we rewrite each rational expression as an equivalent expression whose denominator is the LCD found in Step 1. Step 3, we add or subtract numerators and write the sum or difference over the common denominator. And Step 4, we simplify or write the rational expression in lowest terms. Let's try an example. First, we want to add 15 over 7a and 8 over 6a. Now, using the process that was laid out in the last section, you would find that the LCD equals 42a. And so if you have any trouble finding the LCD, go back to the last section or ask your instructor. For the sake of time and space, we're not going to go through the entire process that has been explained once before. Now that we have an LCD, we need to multiply the numerator and denominator of each fraction so that we have the LCD. In the first fraction, to go from 7a to 42a, we need to multiply by 6. So multiply by 6 in the numerator and denominator, and that will give us 90 over 42a. So now we have an equivalent fraction that we'll plug back in a moment. We need to do the same thing with 8 over 6a. 6a times 7 would give us 42a. So we multiply by 7 in the numerator and denominator. And that will give us 56 over 42a. Taking each of these fractions and putting them in place of the equivalent fractions, we now have 90 over 42a plus 56 over 42a. Once we have two fractions with a common denominator, we can write those over one denominator and add across the top. 90 plus 56 is 146. Now at this point, we would need to find the prime factorization of the numerator and the denominator and factor any like factors, cancel any like factors that we have. The numerator will become 2 times 73. And 73 is a prime number. We can't go any further than that. The denominator will become 2 times 3 times 7 times a. So we see that numerator and denominator have a common factor, which is 2 that we can cancel. And we are left with 73 over, when we multiply the three factors in the denominator, that becomes 21a. Let's try another example. We want to subtract 5 over 2x minus 6 minus 3 over 6 minus 2x. First, we need a common denominator. Now, let's remember that anytime one term, one expression differed by a negative sign, we could factor out a -1. So off to the side, let's rewrite 6 minus 2x as -1 times 2x minus 6. Let's put that back into the expression to see what we can do. This becomes 5 over 2x minus 6 minus 3 over -1 times 2x minus 6. And remember that a negative in the denominator could be moved to the numerator. It could be moved out front. If we were to move it out front, we would have a minus sign and another minus sign, and that would become addition. So we can rewrite this as 5 over 2x minus 6 plus 3 over 2x minus 6. We have a common denominator, 2x minus 6, and 5 plus 3 is 8. At this point, we see that we can factor a 2 from the denominator. So we have 8 is 2 times 2 times 2. The denominator, if we factor out a GCF of 2, we're left with x minus 3. We cancel a common factor of 2 in the numerator and the denominator. And we're left with 4 over x minus 3. Let's try an example where we have a fraction minus a whole number. So here we have 7 over 2x minus 3 minus 3. First, we change the whole number to a fraction. We write it over 1. Now we need a least common denominator. Anytime 1 is involved, the other denominator will be the least common denominator. So here the LCD is 2x minus 3. So we need to multiply the second fraction by 2x minus 3 in the numerator and the denominator. So let's rewrite our equivalent fractions. We have 7 over 2x minus 3 minus 3 times 2x minus 3 over 2x minus 3. Now remember, we would treat this like a -3 as we distribute into this binomial. So because we have a least common denominator, we can write that 1 time 2x minus 3. And in the numerator, we have 7, and we distribute the negative 3. Negative 3 times 2x is negative 6x. Negative 3 times negative 3 is a positive 9. So we combine like terms, and that gives us negative 6x plus 16 all over 2x minus 3. And so we look at the numerator, and it looks like it's possible to factor out a greatest common factor. 6 and 16 have a common factor of 2, and because the leading coefficient is negative, we can factor the negative out as well. And so if we factor out a negative 2, that will leave us with a positive 3x minus 8 over 2x minus 3. And so we see that it was okay to do that, but there will be no factors that cancel at this point. Let's try another example. Here we have 4 over x squared minus x minus 6 plus x over x squared plus 5x plus 6. Now the best way to find the LCD when we have two denominators in this form is to make sure our denominators are factored first. So let's rewrite this with factored denominators. So 4 over, we're looking for two numbers that will multiply to negative 6 but add to negative 1, and that would be negative 3 and positive 2. So x minus 3, x plus 2, plus, let's do the same thing with the second fraction, x over, we want two numbers that multiply to 6 but add to 5, and that would be positive 2, positive 3. So that gives us x plus 2 and x plus 3. Now one way to think about the least common denominator when we have algebraic fractions, we need each fraction to contain all the factors of the other fraction's denominator. So we look, and each fraction has an x plus 2 as a factor. The second fraction has an x plus 3. The first fraction does not have that factor, so we're going to multiply by x plus 3 in the numerator and denominator so that we have the fraction, we have the factor the other fraction had. Similarly, the first fraction has a factor of x minus 3, whereas the second doesn't. So multiply top and bottom by x minus 3. And don't worry about the fact that the order is different in the denominators. When we multiply, order is irrelevant. So those are common denominators. Because we have common denominators, we can write that denominator 1 time in whatever order you choose. Let's just write the smallest first, or what looks like the smallest, x plus 2, and we have an x minus 3, and then x plus 3. It really doesn't matter about the order. Now in the numerators, we would distribute the 4 to the first binomial. That would give us 4x plus 12, plus, because we're adding, we would distribute x into the x minus 3, and that would give us x squared minus 3x. When we combine like terms and rewrite the numerator, it would give us x squared plus x plus 12 over our three binomials, x plus 2, x minus 3, and x plus 3. Now as we look at the numerator, x squared plus x plus 12, typically we would see something like that and hope it factored, or think it factored anyway, and we would be able to go further. But because we can't factor, and the reason why we can't is 12 doesn't have any factors that will add together to give us a positive 1, this would actually be the answer. Let's try another example. 5 over x minus 4 plus 5 over 4 minus x. Again, we're going to use the same trick we did before with this 4 minus x. We know that's the same thing as negative 1 times x minus 4. Or we can move the negative to the front. So this would become 5 over x minus 4. If we move the negative to the front instead of keeping it in the denominator, and instead of plus, this fraction will be minus 5 over x minus 4. We have a common denominator, so we write x minus 4 one time. In the numerator, we have 5 minus 5, which is 0. And anytime we have 0 divided by anything that is not 0, it becomes 0. Let's try another example. 4 over x plus 2 times x minus 2 plus 7 over x plus 2 squared. Just like we did on previous example, let's start by factoring each denominator. The first denominator is factored, x plus 2 times x minus 2, plus the second denominator we can rewrite as x plus 2 times x plus 2. So as we compare each denominator, the first denominator has a factor of x plus 2, a factor of x minus 2, However, the second denominator has 2 factors of x plus 2. So the first fraction needs an additional x plus 2 on top and bottom. Now let's look at the second denominator. It has 2 factors of x plus 2, but it is missing the factor of x minus 2 that the first fraction contains. So we multiply top and bottom by x minus 2. Again, the order is irrelevant. They just happen to be the same here, but they're still least common denominators one way or the other. So we write the least common denominator one time, x plus 2 times x plus 2 times x minus 2. Another way you could write it is x plus 2 squared times x minus 2, whatever floats your boat. In the numerator, to simplify, we distribute the 4 to the first binomial. And that will give us 4x plus 8. We're adding, so plus. We distribute 7 to the second binomial. 7x minus 14. Now we combine like terms in the numerator. And that will give us 11x minus 6 over the 3 binomials that we found before. X plus 2, we can rewrite it this way. X plus 2 squared times x minus 2. The numerator doesn't factor, so we are finished. Let's try another example of subtraction. 5x over 4x plus 20 minus x minus 1 over x plus 5. Just like we have in previous problems, let's factor each denominator first. Gives us 5x over, the GCF of the first denominator is 4, so it gives us 4 times x plus 5, minus the second fraction doesn't factor at all, so just x minus 1 over x plus 5. When we compare the first denominator and the second denominator, we see that the second denominator is missing the factor of 4, so we will multiply top and bottom by that factor of 4. Once we do so, we have one denominator, 4 times x plus 5. In the numerator, we have 5x, and in the second fraction, we're going to take this negative 4 and distribute to both pieces in the binomial that follows. Negative 4 times x is negative 4x. Negative 4 times negative 1 is a positive 4. That will leave us with x plus 4 over 4 times x plus 5. Those 4 do not cancel. There are no common factors in the numerator and the denominator, so we're finished.